In this example, we'd like to demonstrate the use of the SPL exception hierarchy in responding to runtime errors within our code. Also, we want to demonstrate our ability to create custom exception types based on the exceptions provided to us by the SPL. So first, let's look at our custom exception type. Let's see on line 3, we're declaring a class named custom exception that extends or inherits from the logic exception type. So our custom exception class is a kind of logic exception. Well, you'll recall that the logic exception is a kind of exception. So for our class custom exception, not only is it a kind of logic exception, but it is also a kind of exception base class. Within the class definition on line 5, we create a single internal variable called message that's adorned with the protected access modifier. Then on line 6, we create a constructor that takes two parameters, a message variable and a code variable, both of which are defaulted. The message parameter is provided a default value of the empty string, and the code parameter is provided a default value of 5,000. Within the code block of the constructor, we test the value of the message variable. If it is empty, we assign it a value. Then we call the parent class constructor. Notice the syntax, parent : tells us that we are calling a function in the parent class. In this case, our parent class is the logic exception. So we're calling the logic exceptions construct method, passing it the values of the two parameters that our construct method was passed. So in our application, we're simply going to throw exceptions from within a try block. And then we have a set of catch statements that are going to react to the runtime error that we're simulating based on the type of the exception that's thrown. Within the code block of the catch, we're simply printing out the message contained within the exception and then jumping using a goTo statement, and we're jumping to a label which is defined below the catch blocks. And this demonstrates how we can control the flow of execution within our application when a runtime error occurs. In these cases, based on the exception type that's handled, we're jumping to a different label and executing an echo statement identifying the exception type that was handled. So let's see this in action. We're going to throw on line 15 first our custom exception type. So we're going to create a new object of type custom exception and then throw it into the PHP exception handling mechanism. So the output is not what we expected, although we did get the message that we defined within our custom exception type. We can see that we responded to an exception type, an exception base class type. We did not respond to our custom exception type. We jumped to this line of code and executed the responding to exception echo statement. This is not what we wanted. What we wanted was to execute the catch block for our custom exception. So what went wrong? Well, again, with exceptions, the PHP system executes the catch block based on the type of exception thrown. In our case, our custom exception is a type, but it is also a logic exception type, which means it's also an exception base class type. And because we have the exception base class type catch clause defined first, the PHP exception handling mechanism matched our custom exception as a kind of exception base class and executed this line of code. So the lesson here is that when we're defining catch blocks, the catch blocks must be organized from the most specific type of exception to the more general type of exception. So let's reorganize our catch blocks and see what happens. Okay, so now with our catch clauses reorganized from specific to general, let's re-execute our code and see which catch block handles our custom exception. This time, our custom exception catch handler was executed. The custom exception handler jumps to the fourth jump using the goto statement. And if we go down to the fourth jump, this is the code that was executed. Notice that the PHP exception handling mechanism skipped the first catch clause because there is no match. Bad function call exception is a kind of logic exception, which is a kind of base class exception. There is no relation between the bad function call exception and the custom exception. So the PHP exception handling mechanism skipped this catch clause. So now let's execute a logic exception, and we can see that the first two catch clauses were skipped by the PHP exception handling mechanism, and it found a match of the type logic exception with the catch clause on line 29, which handles the type logic exception. So this is a powerful mechanism for redirecting the execution of code based on the type of runtime error that occurs in the application. We can control that flow of execution and the handling of the runtime errors by using the SPL defined exception classes and expanding on those classes by defining our own custom exception types. So now it's your turn. Create a movies class to store data of type movie. The movie class that we created in exercise 10. The movies class should implement the countable interface, the array access interface, and the iterator aggregate interface. Then create a web page to display the contents of movies. Use a for each loop, taking advantage of the iterator functionality, and then repeat the contents using a for loop, taking advantage of the array notation syntax to loop through the contents.